Today we'll be going over Leetcode number 162, which is find peak element. So it states a peak element is an element that is greater than its neighbors. Given an input array nums, where nums at I is unequal to nums at I plus 1, find a peak element and return its index. The array may contain multiple peaks, and in that case, return the index to any one of the peaks is fine. And we're assuming that the outer boundaries are equal to negative infinity. Say we have our array 1, 2, 3, 1. This is nums. Amount of peak elements we're going to find is one peak element, which is the number 3. And the reason for this is because if we check 3 with its neighbors, we see that 3 is greater than 2 and 3 is greater than 1. Therefore, 3 is a peak element. For example, graphing this, we could see that it go up to 2, then up to 3, then all the way down up to 1. So here we see that 3 would be a peak, just like the peak of a mountain. This is how we identify peak elements. So for example, in the array ABC, where A, B, and C are integers, in order for B to be a peak element, B has to be greater than C, and B has to be greater than A. So let's move on to how to solve this problem. So let's say we have our integer 1, 2, 3, 1. What we can actually do to solve this in just 8 lines of code is that we can just go through the array with a simple for loop. And in the array, we're going to check nums at position I and check nums at position I plus 1. And then we're going to check is if nums at I is greater than nums at I plus 1. And if so, we're going to return I. Now, the reason why this works is that because we're going to constantly be checking one element and the element after. If you look at this example, 1, 2, 3, it's all increasing up to the point of 3. But once we check the number after 3, we see it's decreasing. So therefore, in the number ABC, if it keeps on increasing, the number after it is always greater than the number before it. But then once we reach a point B, and then from there on, C is decreasing, we know that B must be greater than A, and B must be greater than C. Therefore, we would know that B is a peak element. This is the simplest and most efficient way to find a peak element. The actual code for this is very simple. So here we are actually just going to run a for loop that goes from I to the size -1. And this is because we are checking I and I plus 1. So once we get to the end of the array and we check it, we're going to go to I and I plus 1, where in that case, I plus 1 would be out of the bounds. And then over here, we're doing exactly what we discovered. We're going to check if nums at I is greater than nums at I plus 1. And if so, we're going to return I, because again, it's going to show that it is going to steadily increase until we find a number where it starts to decrease. And from there, we're just going to return nums at size -1 if we do not find I. If we do find I, we are going to immediately return the index which we find it at.